Welcome to a deep dive into the often, unseen world of machine learning quality assurance.
Yeah.
You've provided us with a fascinating academic paper outlining a process model called CRISP-MLQ,
Okay.
and we're going to break down exactly what this means for you.
It's exciting to think about, isn't it? Everyone's so focused on the latest, AI developments, but so few people are talking about how to make these systems reliable and successful in the long term. That's really where CRISP-MLQ comes in.
It's like, everyone's celebrating the launch of a rocket,
Yeah.
but no one's thinking of how to keep it on course once it's in space.
Oh, that's a great analogy.
Yeah.
And the stakes are high.
Right.
This paper cites surveys showing that a staggering 75 to 85% of ML projects fail to meet expectations.
Wow.
That's a huge red flag, especially as ML applications become increasingly integrated into critical areas like healthcare, manufacturing, and finance.
Right. So what are the main reasons behind this high failure rate? Is it just a bunch of buggy code out there?
Well, it's rarely that simple.
Yeah.
One major issue is the lack of a standardized process for developing ML applications.
Okay.
Think of it like building a skyscraper without a blueprint.
Right.
Teams often just jump into building these complex models without properly defining their goals or ensuring data quality or even establishing robust evaluation methods.
Oh, it's more about the foundation than the fancy algorithm.
Exactly. And that's where CRISP-MLQ comes in.
Yeah.
This process model provides a structured roadmap for developing ML applications that are not only accurate, but also, reliable, maintainable, and adaptable to real-world changes.
I'm already sensing this is going to change how I think about ML.
Yeah.
Well, let's break it down.
Okay.
The paper draws a parallel with CRISP-DM, which is a framework for data mining projects.
Right.
How is CRISP-MLQ different, and why is that distinction important?
Yeah, it's an important distinction. While CRISP-DM is a solid framework for data mining, it doesn't fully address, the unique challenges of developing ML applications that operate in dynamic environments.
Okay.
Think about a self-driving car, right?
Yeah.
It's constantly encountering new situations and needs to make split-second decisions based on ever-changing data.
Right.
So that requires a different approach to quality assurance.
So it's not just about analyzing static data.
Right.
It's about building systems that can learn and adapt on the fly.
You got it.
Okay.
And CRISP-MLQ acknowledges that, from the outset.
Yeah.
It's like building a ship that's designed to navigate uncharted waters,
Okay.
rather than just sail across a calm lake.
I like it.
Yeah.
Okay, so walk us through this roadmap.
Okay.
What are the key phases of CRISP-MLQ?
So the paper outlines 6 distinct phases,
Okay.
each with a specific focus on quality assurance.
Right.
It starts with business and data understanding, then moves through data preparation, modeling, evaluation, deployment, and finally, monitoring and maintenance.
Monitoring and maintenance. That last one already has my attention.
Yeah.
It feels like we're finally addressing the elephant in the room.
Yeah.
That ML models aren't just set it and forget its creations.
You're absolutely right.
Yeah.
But before we get ahead of ourselves, let's start with that first phase, business and data understanding.
Okay.
Might seem straightforward,
Yeah.
but it's where a surprising number of ML projects go astray.
Okay, let's dive in.
Okay.
What makes this initial phase so crucial, and what kind of quality pitfalls should we be aware of?
Well, this phase is all about laying a solid foundation for your ML project.
Okay.
It's about defining the problem you're trying to solve with crystal clear clarity
Yeah.
and ensuring you have the right data to achieve your goals.
Okay.
Think of it like planning a cross-country road trip.
Right.
You wouldn't just hop in the car and start driving, would you?
No, definitely not.
You'd plan your route, check your fuel levels, and make sure you have a reliable map.
I can already see how that translates to ML. You need to map out your goals, assess your data resources, and make sure everything aligns before you even start building a model.
Precisely.
Yeah.
A common pitfall in this phase is failing to clearly define success criteria.
Oh, interesting.
What does it actually mean for your ML application to succeed?
Yeah.
Is it about achieving a certain level of accuracy,
Yeah.
reducing costs, improving user engagement?
Right.
You need to define those metrics up front
Yeah.
and make sure everyone involved is on the same page.
So it's about translating those vague aspirations into concrete, measurable targets.
Yes.
Okay.
The paper emphasizes the importance of having specific, quantifiable goals.
Yeah.
Instead of saying, we want to improve customer satisfaction, you might say, we want to increase our net promoter score by 5 points.
Oh, I see.
That gives you a clear target to aim for and a way to objectively measure your progress.
That makes a lot of sense.
Yeah.
I'm already feeling more organized just thinking about it. What other potential pitfalls should we watch out for in this initial phase?
Another critical aspect is data quality verification.
Okay.
You need to thoroughly understand the data you're working with.
Right.
What are its characteristics? Are there any inherent biases? Are there missing values that need to be addressed?
Yeah.
Failing to address these data quality issues early on can lead to flawed models and unreliable results.
Yeah, it's that old adage, garbage in, garbage out.
Right.
Even the most sophisticated algorithm can't produce meaningful insights from bad data.
Exactly.
Yeah.
So in this initial phase, it's crucial to be meticulous and thorough.
Right.
Don't rush into building models before you've laid a solid foundation of clear goals and high-quality data.
Okay.
It's about setting yourself up for success from the very beginning.
Yeah, building that strong foundation.
Exactly. So it's like we've carefully surveyed the land and gathered the best building materials.
Yeah.
Now the real work begins. The data preparation phase of CRISP MLQ is where we transform raw data into a format that is suitable for machine learning algorithms.
It sounds like this phase is all about rolling up our sleeves and getting our hands dirty.
That's a good way to put it.
Yeah.
This phase often involves a lot of data cleaning, transformation, and feature engineering.
Yeah.
It's about taking that raw data
Right.
and shaping it into something that our ML models can actually learn from.
I imagine this phase is particularly prone to errors, especially if you're dealing with, messy real-world data.
You're absolutely right.
Yeah.
One common pitfall is inconsistency in data formats.
Okay.
Imagine you're building an ML model to predict customer churn,
Right.
and you're pulling data from multiple sources,
Yeah.
your CRM system, your website analytics, and your customer support logs.
Right.
Each of these systems might use different date formats, currency conventions, or even, different ways of representing customer demographics.
So it's like trying to bake a cake with ingredients measured in cups, teaspoons, and grams all mixed together.
Exactly. And just like a poorly measured ingredient can ruin a cake.
Right.
Inconsistent data formats can introduce errors and biases into your ML models.
So what are some practical steps we can take to, mitigate this risk?
The paper recommends establishing clear data standards, like from the outset.
Okay.
Define the expected format for each data field and use automated tools to validate the data against those standards.
Okay.
It's like having a quality control checklist for your data.
That makes sense.
Yeah.
But even if we've, cleaned and standardized our data, we still need to select the right features for our ML model.
Right.
How does Crispy MLQ guide us in that process?
Feature engineering is a crucial part of data preparation.
Okay.
It's about creating new features that might be more informative for our models than the raw data alone.
Okay.
Let's go back to that customer churn example, right?
Yeah.
We could create a feature that represents the average time a customer spends on our website per visit.
Right.
Or a feature that captures the number of times a customer has contacted customer support in the past month.
Right. Okay.
These engineered features might be more predictive of churn than the individual data points on their own.
So it's about adding context and depth to our data.
Yes.
Okay.
And Crispy MLQ emphasizes the importance of carefully selecting and evaluating these engineered features.
Yeah.
We don't want to blindly add features that don't actually improve the model's performance.
Right.
It's about finding that sweet spot between informative features and model complexity.
I imagine there are some potential pitfalls here as well.
Yeah.
What should we watch out for?
One common trap is the cursive dimensionality.
Oh, okay.
Adding too many features can actually make it harder for our models to learn meaningful patterns.
Oh, interesting.
It's like trying to find a needle in a haystack and you keep adding more hay to the pile.
Yeah.
CRISP MLQ encourages us to be selective and only include features that we have strong reason to believe are relevant to our problem.
So it's about being strategic and thoughtful in our feature engineering.
Yeah.
Not just throwing everything into the model and hoping for the best.
Precisely.
Right.
And another crucial aspect of data preparation is handling missing values.
Okay.
Real-world data is often incomplete.
Yeah.
And we need to decide how to deal with those gaps.
Right.
Should we simply remove data points with missing values?
Okay.
Or should we try to fill in those gaps using imputation techniques?
I've always found data imputation to be a fascinating concept.
Yeah.
It's almost like we're playing detective trying to fill in the blanks in our data story.
That's a great way to think about it.
Yeah.
And there are many different approaches to imputation,
Right.
from simple techniques like replacing missing values with the average value for that feature,
Okay.
to more sophisticated methods that use machine learning algorithms to predict the missing values.
I can see how choosing the right imputation method could have a significant impact on the accuracy and reliability of our models.
Absolutely.
Yeah.
CRISP-MLQ guides us to carefully evaluate the different imputation options
Right.
and choose the one that best suits our data and our problem.
Okay.
It's about making informed choices at each step of the data preparation process.
This has been a really insightful look at the often overlooked but critical phase of data preparation.
Yeah.
It's clear that the quality of our data and how we prepare it can make or break the success of our ML projects.
I couldn't agree more.
Yeah.
It's like building a house.
Okay.
You can have the grandest architectural plans,
Right.
but if the foundation is weak, the whole structure will crumble.
Right.
Similarly, in ML, no matter how sophisticated your algorithms are,
Yeah.
they can't overcome the limitations of poorly prepared data.
Now that we've laid this solid data foundation,
Yeah.
I'm excited to move on to the next phase of CRISP-MLQ,
Okay.
the stage where we actually get to build our ML models. But before we dive into that,
Here.
I want to touch on one point that I found particularly intriguing in the paper.
Yeah.
It's this idea that ML systems can actually influence their own behavior over time through feedback loops.
That's a fascinating and often overlooked aspect of ML development.
Yeah?
It's like a self-fulfilling prophecy.
Okay.
Imagine an ML model designed to recommend products to users based on their past purchases.
Right.
If the model consistently recommends certain types of products,
Yeah.
it can inadvertently shape user behavior, leading them to buy those products even more frequently.
Oh, interesting.
This, in turn, reinforces the model's belief that those products are popular, leading to even more recommendations of those products, and so on.
It's like a snowball effect.
Yeah.
Where the model's initial recommendations create a feedback loop that influences future recommendations.
Exactly.
Yeah.
And this phenomenon can have both, positive and negative implications.
Right.
On the positive side, it can lead to, more personalized and relevant recommendations over time.
Okay.
But on the negative side,
Yep.
it can create filter bubbles and reinforce existing biases in the data.
So it's a double-edged sword.
Yeah.
It highlights the need to carefully monitor these feedback loops and ensure they're not leading to unintended consequences.
Absolutely.
Yeah.
And this ties back to the importance of the monitoring and maintenance phase of CRISP-MLQ, which we'll discuss in more detail later.
Okay.
It's crucial to have mechanisms in place to detect these feedback loops and make adjustments as needed to ensure our models remain fair and unbiased over time.
Okay, now that we've addressed that intriguing point,
Yeah.
I think we're ready to move on to the heart of the ML development process.
Okay.
The modeling phase.
Right.
This is where we finally get to choose our algorithms and build those predictive machines.
I am excited to dive into this phase with you.
Yeah.
It's where we get to apply our creativity and technical expertise to build models that can extract meaningful insights from data and make accurate predictions.
Let's explore the different modeling techniques available, the factors that influence our choice of model, and the potential pitfalls we need to avoid. All right, we've reached the modeling phase of CRISP-MLQ,
Yeah.
where we actually get to build these intelligent systems.
Right.
I'm curious, with all the buzz about deep learning and these, complex algorithms,
Right.
how do we choose the right model for a given problem?
Yeah.
It can't be a one-size-fits-all situation.
You're right. It's definitely not one size fits all.
Yeah.
It's more like choosing the right tool from a well-stocked toolbox.
Yep.
Sometimes you need a hammer, sometimes you need a screwdriver,
Yeah.
and sometimes you need a very specialized instrument.
Okay.
That's where the no free lunch theorem comes in.
Okay.
It tells us that no single model will outperform all others on every problem.
Right.
Each model has its strengths and weaknesses,
Yeah.
and our job is to find the best fit.
So it's about matching the model's capabilities to the specific nuances of our problem.
Exactly.
Yeah.
Let's say we're working on a fraud detection system for credit card transactions.
Okay.
A simple linear model might struggle to capture the complex patterns of fraudulent behavior.
Yeah.
In this case, a more powerful model, like a deep neural network, might be a better choice.
Okay.
It can learn these intricate relationships and detect subtle anomalies that a simpler model might miss.
It's like using a high-powered microscope to examine something tiny and complex,
Yeah.
instead of just relying on a magnifying glass.
That's a great analogy.
Yeah.
But even though depth learning has become incredibly popular,
Right.
it's not always the best solution.
Okay.
Sometimes a simpler model might be more appropriate, especially if interpretability is a key requirement.
What do you mean by interpretability?
Interpretability means being able to understand why a model makes a particular prediction.
Okay.
This is crucial in domains like healthcare or finance, where we need to be able to explain the reasoning behind a model's decisions.
Right.
A simple decision tree model, for example, is highly interpretable. You can easily trace the path of decision rules that led to a specific prediction.
Right.
Deep learning models, on the other hand, are often referred to as black boxes because their internal workings can be difficult to decipher.
So there's a trade-off between model complexity and interpretability.
Exactly.
Yeah, okay.
CRISP-MLQ encourages us to carefully consider this trade-off when selecting a model.
Right.
If interpretability is paramount, we might opt for a simpler model, even if it means sacrificing a bit of predictive accuracy.
Okay.
Conversely, if we're primarily concerned with accuracy and have less need for interpretability, a more complex model might be the better choice.
This is really making me rethink the way I approach model selection.
Yeah.
It's not just about chasing the latest and greatest algorithms.
Right.
It's about choosing the right tool for the job.
Absolutely. And it's not just about the model itself, it's about the entire modeling process.
Okay.
CRISP-MLQ emphasizes the importance of rigorous model validation and testing.
Yeah.
We need to make sure our models are not only accurate, but also robust.
Okay.
Meaning they can perform well on unseen data and in unexpected situations.
So it's like putting our models through a series of stress tests to make sure they can handle the real world.
Exactly.
Yeah.
A common pitfall in the modeling phase is overfitting.
Right.
This happens when a model learns the training data too well,
Okay.
effectively memorizing the specific patterns in that data instead of learning the underlying concepts.
Right.
When presented with new data.
Yeah.
An overfit model often fails to generalize and makes inaccurate predictions.
It's like a student who crams for an exam by memorizing the textbook, but can't apply the concepts to solve new problems.
That's a perfect analogy.
Yeah.
CRISP-MLQ provides techniques to mitigate the risk of overfitting, such as using cross-validation to evaluate the model on multiple subsets of the data, and applying regularization techniques that penalize overly complex models.
So it's about striking that balance between model complexity and generalization ability. Okay. We want a model that's sophisticated enough to capture the essential patterns in the data, but not so complex that it becomes overly specialized and brittle.
Now, once we've built and validated our model, it's time to move on to the evaluation phase of CRISP-MLQ.
Okay.
This seems like a critical step to ensure our models are truly meeting our expectations.
Yeah.
What are the key considerations here?
The evaluation is where we really put our models to the test.
Okay.
We assess their performance using metrics that align with our business goals and the specific requirements of our application. Is accuracy our top priority?
Right.
Or are we more concerned with precision or recall?
Okay.
Or perhaps we're working on a ranking problem and we need to evaluate the model's ability to correctly order items.
It sounds like choosing the right evaluation metrics is just as important as choosing the right model.
Absolutely.
Yeah.
The paper emphasizes the importance of using metrics that are meaningful and relevant to the problem we're trying to solve.
Right. And just like in the data preparation phase, where we stress the importance of avoiding garbage in, garbage out, in the evaluation phase, we need to be wary of data leakage.
I've heard of data leakage. It sounds a bit sneaky.
Right.
Can you explain what it is and why it's so detrimental?
Data leakage happens when information from the test set, the data we use to evaluate the model, inadvertently leaks into the training process.
Okay.
This can lead to overly optimistic performance estimates because the model has effectively seen a preview of the answers during training.
Oh.
It's like giving a student a sneak peek at the exam questions before the actual test.
So it's like cheating.
Exactly.
No wonder it's so detrimental.
Exactly.
Yeah.
CRISP-MLQ provides several strategies to prevent data leakage, such as carefully separating the training and test sets, using techniques like cross-validation, and being mindful of how we pre-process and engineer features.
It sounds like meticulousness and attention to detail are essential for a clean and reliable evaluation process.
Absolutely.
Yeah.
We need to be vigilant at every step
Right.
to ensure we're getting an accurate assessment of the model's true performance.
Okay.
A flawed evaluation can lead us to believe a model is ready for deployment when it's actually not, potentially leading to costly mistakes and unreliable results.
Now, assuming we've thoroughly evaluated our model and are confident in its performance, we move on to the deployment phase of CRISP-MQ.
Okay.
This is where our model leaves the controlled environment of development and enters the real world.
Right.
What are some of the challenges and considerations that come into play during deployment?
Deployment is where the rubber meets the road, right? It's the culmination of all our hard work, where our model gets to demonstrate its value in a real-world setting.
Okay.
But it also presents a new set of challenges. We need to ensure a smooth transition from the development environment to the production environment, where the model will be used in real time. This often involves considerations like scalability, latency, and integration with existing systems.
So it's not just about building a great model. It's also about making sure it can function effectively in the wild.
Precisely.
Okay.
Imagine we've built a fantastic recommendation engine for an e-commerce platform in the development environment. It might perform flawlessly on a small sample of data. But when we deploy it to the live website, it needs to handle millions of users making requests simultaneously. That requires a different level of engineering and infrastructure.
It's like the difference between a small bakery that makes a few cakes a day and a large factory that produces thousands of cakes per hour.
Exactly. And it's not just about handling the volume of requests. It's also about delivering those recommendations quickly. Users expect real-time responses, especially in applications like online shopping or personalized content delivery. So latency. The time it takes for the model to process a request and return a prediction is a critical factor in deployment.
It's like the difference between ordering a meal at a fast food restaurant and waiting for a 5-course meal at a fine dining establishment.
You're getting it. And beyond performance considerations, we also need to think about how our model integrates with the existing systems and workflows. Does it need to communicate with a database? Does it need to trigger other actions based on its predictions? Deployment involves carefully considering all these integration points to ensure a seamless transition.
So deployment isn't just a technical task. It's also a strategic one.
Absolutely.
Okay.
CRISP-MQ emphasizes the importance of careful planning and communication during deployment. We need to involve stakeholders from different teams, including engineers, data scientists, and business analysts, to ensure everyone is aligned and the deployment goes smoothly.
It sounds like a well-coordinated dance where everyone needs to be in sync to avoid stepping on each other's toes.
That's a great way to put it. And even after the model is successfully deployed, our work isn't done. We enter the final and arguably most important phase of CRISP-MQ, monitoring and maintenance.
This is the phase that really sets CRISP-MQ apart from other ML development frameworks. It acknowledges that deploying a model isn't the finish line. It's just the beginning of a continuous journey.
You're absolutely right. The real world is dynamic and ever-changing. User behavior evolves. Data distributions shift. And new patterns emerge. A model that performed brilliantly yesterday might start to struggle today if it's not constantly monitored and adapted to these changes.
It's like a garden. You can't just plant the seeds and walk away. You need to water it, weed it, and prune it to keep it healthy and thriving.
That's a perfect analogy. Monitoring and maintenance is all about tending to our models, ensuring they remain accurate, relevant, and reliable over time. This involves setting up monitoring systems to track key performance indicators, detecting anomalies that might indicate a decline in performance, and having strategies in place to update the model when needed.
So what are some of the specific tasks involved in monitoring an ML model in production?
We need to keep a close eye on various metrics depending on, the nature of the application. We might track accuracy, precision, recall, or other metrics that reflect the model's ability to make correct predictions. We might also monitor latency to ensure the model is responding quickly enough to user requests. And we might track resource utilization like CPU and memory usage to make sure the model is running efficiently.
It's almost like giving our model regular health checkups to make sure everything is functioning as expected.
Exactly. And if we detect any signs of trouble, like a drop in accuracy or an increase in latency, we need to investigate the cause and take corrective action. This might involve retraining the model on new data, fine-tuning its parameters, or even redesigning parts of the system.
So it's a continuous cycle of monitoring, analysis, and improvement.
Precisely. And the frequency of these updates can vary widely depending on the application. Some models might need to be retrained daily or even hourly, while others might only require updates every few months. CRISP MLQ encourages us to develop a tailored monitoring and maintenance plan that aligns with the specific needs of our application.
This entire conversation has been incredibly insightful.
Good, I'm glad.
It's really highlighted the importance of a structured and holistic approach to ML development.
Yeah.
One that goes beyond just building fancy algorithms. CRISP MLQ provides a comprehensive roadmap for creating ML systems that are not only accurate, but also reliable, maintainable, and adaptable to the ever-changing demands of the real world.
I'm glad you found it valuable.
Yeah, definitely.
As machine learning continues to permeate every aspect of our lives, it becomes increasingly important to prioritize quality and reliability.
Yeah.
CRISP MLQ equips us with the tools and mindset to build ML systems we can truly trust.
I think our listeners are walking away with a whole new appreciation for the often unseen but critically important world of machine learning quality assurance.
Yeah, me too.
We've covered a lot of ground today, from defining clear business goals to monitoring models in production.
Right.
But I think the key takeaway is that quality isn't just an afterthought.
Yeah.
It's a fundamental principle that needs to be embedded in every stage of the ML development lifecycle.
Absolutely.
By embracing CRISP MLQ, we can create ML systems that truly deliver on their promises and pave the way for a future where intelligent technology is both powerful and dependable.
Well said.
And remember, this is just the beginning of the journey.
Right.
As the field of machine learning continues to evolve at an incredible pace, we'll need to constantly adapt and refine our approaches to quality assurance.
Absolutely.
But with frameworks like CRISP MLQ as our guide, we can navigate the complexities and build a future where AI is both innovative and trustworthy.
That's a perfect note to end on.
Thanks for joining us on this deep dive.
Yeah, thanks for having me.
Until next time, keep exploring, keep questioning, and keep pushing the boundaries of responsible AI development.